data structure of Python containers. How do you keep your lunch? Where's your lunch? Do you have a lunch now? What is your lunch? Fried rice. How do you keep your fried rice? Where's your fried? Tupperware. Tupperware is a container. Tupperware is a container. So you keep your fried rice in your container. Here we have data. Data can be in long array, can be in two-dimensional space. We want to keep it in a container. So that is a container, right? So we call it data structure. To be fancy, we call it data structure. Rather, it is just Python containers. So we have a sequence. Just now you saw string. String is a sequence, right? String is a long sequence. It is in fact a list. Yeah, string was made out of a list. And then there's a tuple. So for list, we use a square bracket. Yeah, we call it bracket. For tuple, we use somewhat a bit circular bracket, but the right name is parenthesis. Yeah. Yes. This is a set, just like in mathematics, set, right? To write a set, we write a curly bracket, or we call it braces. And then we have dictionary, just like your dictionary. Your dictionary has two types of element. The first one is the word. The next one is the explanation of the word. So the first word is actually the key. The next is the explanation. So we have in dictionary, we have two types of elements. One is the key, the other one is explanation or value or anything that you want to store. Okay, when I call brand, I get sport. I call model, I get Mustang. So you get to see that double dot. Yeah, key and the explanation is divided by a double dot. Okay, so that is list, tuple, set, and dictionary. So most of the time, when we want to store, we usually use list. Okay, so that would be the last lecture for today, actually, on list and array. I have to finish until then. Okay, so examples. Let's look at some examples. Okay, this is a bracket, right? So a bracket, we use a bracket. So what it is? It is a list. Yeah, it is a list. This is a /n means space. Skip a space, just like in C language. Give me another space and then it will start printing. So in list 2. So what it means, this is 0. This is 1. This is 2. The output would be in list 2 is 5. Okay, so shift enter. So output is 5. The one on top, the space, empty space is because of /n. So you want to skip a space, skip a line, you put /n. Okay, sum int list. We can do a summary. What sum does? Sums up elements of the list. So 25. I have 25. You plus everything. You see, you can even have to just add up all the elements. The sum int list. And then append. Append, just add another one. See, append 11. Originally it was 1, 3, 5, 7, 9. Now when I append, I get extra one more element at the end, 11. Okay. Okay, of course, I'm printing it out. Then pop. Pop is to remove. To remove. So when you put that, when you write pop empty bracket there, then it will remove the last element. So pop remove, and then I print again. Originally it was 11. Oh, I popped 11 out. Okay. and then I end up with the without 11, of course. And okay, here again, this plus sign is concatenate. Just add up more, concatenate. Yeah, so you get to add up more. Right, just now append this one entered. This time around you added, you use concatenate. So two lists we combine together. So this is a new list. Yeah, this is a new list we combine with our own old list just now. Okay, list time 3. See, it's not times 3, rather it replicate the list 3 times. 1, 2, 3. Oh, it does not do element wise multiplication. Yeah, rather it just duplicate 3 times. Okay, insert 2, 4. You see, where is that? List 3. Insert 2, 4. 0, 1, 2. So the first 2 here is the location to add number 4. The first one is location, 4 is the item to add. Okay, so you can also sort, use a function called sort, reverse through. Okay, sort, reverse through. So which one is that? Okay. If you just sort, it's going to be 1, 3, 4, 5, 7, 9. Reverse, just the reverse way. Okay, a simple array manipulation. Okay. There's another way of writing a list. This is another way of writing a list. To write a list, we use range 0 to 12. Range 0 to 12 means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But I put here 2 with increment of 2, step size of 2. So 0, 2, 4, 6, 8. If I just write 0 to 12, okay, just simply change for you. So you get 0 until 11. It doesn't try the last one. The last one is not inbound, outside. So 0 to 11, 0 to, let's say 11, it's going to do until 10 only. So the last one is will not be done actually. Okay. So if I put 2, then the increment is 2. 0 to 11 or 0 to 10, I should say. The increment is 2. So this is an example of just creating a series of numbers. And then this series of numbers, actually, I want it to be the container. I want it to be is a list. So you get a list. These are base. Of course, on top, we just simply created list. I just simply created list that I like. Okay, here. Rather here, I use the range, create numbers, and then make it as a list. Okay, that's also possible. The next thing is now tuple. Tuple, as I said, is a curly bracket. So it exists as an example. I have 3 numbers. I want to keep it as a tuple. Okay, here, I can also keep tuple in the form of each element being a string. Apple, banana, cherry. Of course, a string. Well, to write a string, we use a code sign. Okay, example. This is an example of a code sign. Where is that? I can also use single actually. You can use double or single, up to you. Up to you. Sometimes maybe you feel like you're more comfortable with single code. You can also do that. It won't complain. Yeah, you can print out full. Okay, so it won't complain actually. It's both a string, just that how you like. You can use single code. You can also use double code. And you can also do a mixture of type of element. See, for the first one is, this is actually a tuple. Same goes to lists. List or tuple, you can change as you like. change the type for the data that you want to store. For example, the first type is string. Second type is an integer. The third type is a float. The fourth one is a Boolean. Right? You can change all kind of data type to store as a tuple or a list element. In C language, you can't do it. It will complain. Python is very flexible. Okay? Okay, then we have, okay, same way. To access a particular element, we use a bracket and then we write the index. The index always starts with 0. Here, the first element in a fruit's tuple is 0. Okay, second, and then -1 is the last. Okay, -1 I'm counting from right to left. We are so used to counting from left to right. Left is 0, 1, 2, 3, right? If I start from here, for example, if I write -1, I'm starting from right to count. So which means I'm cutting from cherry. Cherry, banana, apple means -1, -2, -3. You see? Okay, now cherry you get. You see, when I put -1, you get cherry. -2, you get banana. You see? Okay, banana also, of course, if we count from left to right, banana is 0, 1. Banana is 1. Okay. This mixed one is here. Yeah. So if we want the last one again, just write -1. Don't need to write 0, 1, 2, 3. Right. You can just count from right also. That's how index works. Okay. So when I use the standard way, most of the time in Python coding, we use list. We don't really use tuple. Yeah. For example, I want to use tuple. Like for example, for coordinate system, Cartesian coordinate, x and y, we usually write in a tuple form. Okay. And whatever that, for example, here we have tuple operation, we add addition, we add multiplication, and then same thing. We have a length also. We can compute for tuple, just like what we did for list. Okay. Addition means combining two tuples. Multiplication means you just duplicate twice. Okay. For example, yeah, as I said, there's no Cartesian coordinate. You want to represent in a form of a tuple usually. Okay. Now we have a set. Create set. In mathematics, you teach students set, right? A mathematician creates Python. So the set works similarly. Yeah. For example, this is a set. This set has C, D, E, F, and E. So E is twice, right? 2 times E, right? If you print, yeah, if you print Y1, print. Okay, I have it here, so I just. C, D, E, F, E. So it won't say E twice, only once, because it is a set, right? That's how set behaves. You can also ask D, this is a D in Y. It's like a question mark. Yeah, D in Y. It says what? True. It's D. Oh, yes. Let's say, right, for example, Z. Z is in Y. False. Yeah. It's like just asking questions. So you create, now you're creating a new one. And then is Y1 equals to Y2? You're not comparing two sets. Are they the similar set? Of course not, because here we have X as X prime element also. Right? So this is another one, Y3. And then I have intersection. y2 intersection y1, right? You do intersection in set, right? Yeah, you can also do union. Yeah, you can do union, you can do intersection, you can do whatever that you do with set in mathematics. Okay. Okay, so that is example of set. Usually don't use it unless you want to do some mathematical problem which involves set. You might want to use it. Otherwise, you don't really use it. Next is dictionary. As I said, the word dictionary is simply just like the dictionary that you use. Right? The dictionary has key and also its element. I should say this is the key, and the you see the double dot here. The key is the name, and then double dot. The name here represent Alice, and then another key is age, and then the age is 20. Then of course the grade is A, and so on and so forth. Okay. Okay. So again, this time around we use same like set, but now we have key, and then we have double dot, and then it's whatever value. Okay. To access, you can just write then the container, which is the dictionary, and then the key to get. Okay. Right. Okay. So this is also like somewhat important. So this is because we can hold extra information, right? Maybe student 1 is this, student 1 is Alice, then you want to keep student 2, right? And student 3 and so on, so forth. Okay. You can always add also. Yeah. So here accessing by key, and here you want to update or you want to add. For example, you want to add student's email. You can also do that, right? Once you print, yeah, you get to see, okay, the student now we have extra key, which is extra key, which is the email, and the student's email. Yeah? So just write the extra new key, and then you add. Or you want to update, use the same old key and update with new value. Right? And same thing, you can remove, pop to remove, clear to empty the dictionary. Okay, so this is yet another example. So student 1, so this one S1, S2 are the keys now. S001 represents student 1, S002 represents student 2. And then in the student, there's another dictionary. So dictionary in dictionary. Okay. Okay, this is already a dictionary, right? So this is yet another dictionary. Okay. All right. So this is a mixture, a little bit of mixture of everything. But here I'm creating a dictionary using a function called zip. Zip is like a map, key to value. So key, for example, apple 3, orange 4, banana 4, 2, cherry 10. It will just do the map. That's the purpose of zip. Okay. And then this dictionary, of course, we are creating dictionary out of it. Now yet another way of creating dictionary rather than doing it one by one.